Imagine opening your laptop tomorrow morning and typing a single sentence. Plan my business trip to Tokyo. A few moments later, flights have been researched, hotels have been compared, meetings have been scheduled, a complete itinerary has been created, and the confirmation emails are already waiting. Not because a human assistant completed the work, but because an artificial intelligence system did it. For decades, software has followed instructions. You click, you type, you decide. The software obeys. But a new generation of intelligence is rewriting that relationship. Systems that don't just answer questions. Systems that can pursue goals, make decisions, use tools, and take action. They're called AI agents. And many experts believe they represent the next major evolution of computing. But what exactly is an AI agent? How does it think? How does it make decisions? And why are some people calling this the end of software as we know it? Today, we're going inside the technology that could transform how humans work with machines. This is how AI agents really work. To understand AI agents, we first need to understand the limitation of traditional AI assistants. Systems like ChatGPT can be remarkably capable. They can explain complex ideas, write reports, generate code, summarize information, and answer questions across thousands of subjects. In many ways, they function like incredibly knowledgeable consultants. Ask a question, and they provide an answer. Describe a problem, and they suggest a solution.
Okay, that looks good. What about transportation? Perfect. I'll compare these options.
But when it comes time to act, the responsibility still belongs to the human. Imagine asking ChatGPT to plan your Tokyo trip. It can recommend airlines, suggest hotels, outline an itinerary, and even draft emails. But you still need to open the travel websites, compare prices, book the flights, reserve the hotel, send the emails, and update your calendar. The AI provides information. You perform the work. Early language models were largely isolated from the outside world. Modern systems have begun to bridge that gap through capabilities such as web browsing, code execution, and tool integrations. But access to tools alone does not create an AI agent. The defining characteristic of an agent is autonomy, the ability to pursue a goal through multiple steps, evaluate progress, adjust its strategy, and continue working toward an outcome without requiring constant human direction. Traditional chat systems generally operate one interaction at a time. A prompt arrives, the model generates a response, and the interaction ends. The system may be intelligent, but it is not pursuing a goal over time. It is reacting, not acting. So engineers began asking a different question. What if artificial intelligence could do more than generate information? What if it could use information to achieve outcomes? That question led to the emergence of AI agents. So what exactly is an AI agent? At first glance, the answer seems simple. An AI agent is an artificial intelligence system that can pursue a goal and take actions to achieve it. But that definition doesn't fully capture what makes agents different. To understand that, think about how a human assistant works. Imagine asking an assistant to organize a business trip. The assistant doesn't immediately start booking flights. First, they gather information. Where are you going? When are you leaving? What is the budget? Next, they evaluate the options.
This flight is an hour faster but costs more. Let's check hotels. This hotel has better views but the other is cheaper. Uber is faster but the taxi is more reliable. This meeting overlaps. I'll adjust it.
Which flights are available? Which hotels are nearby? Which schedule makes the most sense? Then, they create a plan. And finally, they take action. Making reservations, sending confirmations, updating calendars, completing the task. An AI agent follows a remarkably similar process. It observes, it reasons, it plans, and it acts. These four capabilities form the foundation of nearly every modern AI agent. Observation allows the agent to understand its environment. Reasoning allows it to analyze information and make decisions. Planning allows it to break complex goals into manageable steps. And action allows it to interact with tools and software in the real world. Unlike traditional chatbots, an agent doesn't simply generate a response and stop. It continues working toward an objective, step by step, decision by decision, action by action, until the goal is achieved. In computer science, this continuous cycle is often called an execution loop. Traditional software follows a rigid sequence of instructions. If something unexpected happens, the software may fail, but an AI agent can evaluate what happened, adjust its approach, and continue toward the goal. It introduces something software has rarely possessed before: adaptability. This may sound like a small difference, but in reality, it represents a fundamental shift in how software operates. For decades, computers have waited for instructions. AI agents are designed to pursue outcomes, and that single distinction changes everything. Every decision an AI agent makes begins with observation, because before an agent can reason, before it can plan, before it can take action, it first needs information. Humans do this naturally. Before planning a trip, you check flight prices. Before driving somewhere new, you look at a map. Before making an important decision, you gather facts. AI agents operate in much the same way. They begin by collecting information from their environment. That information can come from many different sources: emails, documents, websites, databases, application programming interfaces, even cameras, sensors, and connected devices. The agent continuously gathers signals from the world around it. But observation is about more than simply collecting data. The real challenge is determining what information matters. Imagine asking an AI agent to schedule a meeting. It might examine your calendar, check participant availability, review time zones, analyze scheduling conflicts, and identify the best available option. What appears to be a simple task may require the agent to process information from multiple systems simultaneously. But there is a massive engineering challenge hidden inside this step. The digital world is full of noise. Emails contain casual conversations. Documents contain irrelevant details. Websites constantly change. Databases may contain millions of records. The agent cannot examine everything at once. Instead, it uses specialized retrieval systems to identify the most relevant information and place it into the model's context window. A form of temporary working memory. This allows the model to focus on the information that matters right now, without becoming overwhelmed by digital noise. In many ways, observation serves as the eyes and ears of the agent. Without it, the agent operates blindly. With it, the agent gains awareness of its environment, and that awareness becomes the foundation for everything that follows. Because once an agent understands what is happening around it, it can begin to answer a more important question: what should happen next? Once an AI agent has gathered information, the next challenge is making sense of it. This is where reasoning begins, and at the center of that reasoning process is a large language model, the same technology that powers systems like ChatGPT. But unlike a standalone chatbot, an AI agent is not reasoning in isolation. It is reasoning in context. It has access to information gathered from the world around it: emails, calendars, documents, databases, websites. And its job is to determine what all of that information means. Imagine an agent helping you schedule an important meeting. Observation has already collected the facts: the participants, their calendars, their time zones, their availability. Now the agent must evaluate the situation. Which time works best? Which conflicts are acceptable? Who has the highest priority? What outcome is most likely to satisfy everyone involved. This is not simply information retrieval. It is decision-making. The agent is transforming data into judgment, and this is where modern artificial intelligence becomes remarkable. Because reasoning is not the same as calculation. Traditional software follows rules. If this happens, do that. If a condition is true, execute a predefined action. But reasoning allows the system to navigate uncertainty, incomplete information, conflicting priorities, unexpected situations, the kinds of problems humans encounter every day. To navigate this uncertainty, the agent doesn't simply jump to a conclusion. It often breaks problems into smaller reasoning steps, evaluating possibilities, comparing outcomes, testing assumptions, and gradually moving toward a decision. Some advanced systems explore multiple possible approaches before selecting the most promising path, not because they truly understand the world the way humans do, but because they have learned statistical patterns from vast amounts of data. This is not human understanding. It is probabilistic reasoning built from patterns learned across enormous collections of information. And yet, those patterns can often produce surprisingly effective decisions. Those decisions become the foundation of the next stage. Because once an agent determines what should happen, it must decide how to make it happen. It must create a plan. Reasoning determines what should happen. Planning determines how it will happen. And this is where AI agents begin to look remarkably human, because humans rarely solve complex problems in a single step. We break them down. We create objectives, priorities, checklists, roadmaps. And AI agents do something similar. Imagine giving an agent a simple instruction. Plan my business trip to Tokyo. At first glance, that sounds like a single task. But to an AI agent, it is actually a collection of smaller problems. Research available flights, compare prices, identify suitable hotels, calculate travel times, estimate costs, build an itinerary, schedule meetings, generate a final report. What appears to be one objective becomes many interconnected tasks. This process is known as task decomposition. The agent takes a large goal and breaks it into manageable pieces. Then it determines the order in which those pieces should be completed. Some tasks depend on others. You cannot schedule a meeting until you know when the flight arrives. You cannot estimate travel costs until accommodations have been selected. The agent must understand these relationships and organize them into a logical sequence. But a static checklist is fragile. In the real world, websites crash, server connections time out, flight prices change, hotel rooms disappear, and software systems return errors. If an agent blindly follows its first plan, one unexpected roadblock could stop the entire process. So modern agents need more than a checklist. They need adaptive planning. As each step is completed, the agent checks what happened. Did the action work? Did the result match the goal? Did new information change the situation? If a preferred hotel is suddenly sold out, the agent does not simply stop. It loops back, reviews the failure, updates the plan, searches for alternatives, and chooses a new path forward. Planning transforms intelligence into strategy. Observation provides awareness. Reasoning provides judgment. But planning creates direction. Without a plan, an agent may know what needs to be done, yet have no reliable path to achieve it. With a plan, every action becomes part of a larger objective. And once that roadmap exists, the agent is ready for the final stage. Action. Everything we have explored so far, observation, reasoning, and planning, has taken place inside the agent. But no matter how intelligent the system may be, none of it matters without action. Because a plan that is never executed is just an idea. And this is where AI agents fundamentally separate themselves from traditional chatbots. They don't stop at recommendations. They don't stop at suggestions. They don't stop at generating text. They act. Imagine asking an AI agent to schedule a meeting. A chatbot might tell you the best available time. An agent can go further. It can open your calendar, create the meeting invitation, send notifications to participants, update schedules, and confirm that the event has been successfully created. The difference may seem small, but it changes the role of artificial intelligence entirely. The system is no longer acting as an advisor. It is becoming an operator, a digital worker capable of interacting with software on your behalf. And to do that, it needs tools. Just as humans use browsers, email applications, calendars, spreadsheets, and databases, AI agents use digital tools to accomplish tasks. But using tools requires another layer of intelligence. The agent must decide which tool is appropriate for each task. Imagine an agent trying to verify the status of a flight. A calendar tool cannot help. An email application cannot help. A spreadsheet cannot help. So the agent evaluates its available options, identifies the correct tool, and selects the one most likely to complete the objective. In many ways, it is managing a digital tool belt, a collection of capabilities it can call upon when needed. Search the web, read a document, query a database, send a message, update a record. Each action begins with a decision: which tool should I use? And once that choice is made, the agent begins executing the task. Every action is translated into a sequence of software operations: opening applications, retrieving information, submitting requests, updating records, triggering workflows, moving data between systems. What appears to be a simple task from the outside may involve dozens of individual actions occurring behind the scenes. This is one of the most important ideas in modern artificial intelligence. The intelligence itself is only part of the system. The real power emerges when intelligence is connected to tools. Because a brilliant mind with no ability to interact with the world can only offer advice. But a mind connected to tools can create outcomes. And that transformation is redefining what software can do. For the first time, artificial intelligence is moving beyond conversation and into execution. But this raises an important question. How do AI agents actually use these tools? How does a language model communicate with calendars, databases, web browsers, and software platforms it was never originally designed to control? The answer lies in a hidden layer of technology that most users never see. But this raises an important question. How does an AI agent actually interact with the outside world? How does a language model send an email, update a spreadsheet, query a database, or schedule a meeting? After all, large language models were originally designed to generate text, not control software, not operate applications, and not interact with the internet directly. So how do they do it? The answer lies in a hidden layer of technology that sits between the AI model and the outside world. A layer built from tools, interfaces, connectors, and software integrations. Imagine you ask an AI agent to schedule a meeting. The language model itself cannot directly open a calendar application. It cannot physically click buttons, and it cannot manually create events. Instead, it generates a structured request, a message describing exactly what needs to happen, who should attend, when the meeting should occur, and how long it should last. That request is then passed to another system, a software interface specifically designed to communicate with the calendar. These interfaces are known as APIs, Application Programming Interfaces. In simple terms, an API is a doorway, a standardized way for one piece of software to communicate with another. Every day, billions of API requests move across the internet. Banking systems use them, airlines use them, cloud platforms use them, social media platforms use them, and AI agents rely on them constantly. The Calendar API receives the request, creates the event, and returns a response. The AI reviews the result, confirms the task succeeded, and moves on to the next step. What appears to be a single intelligent action is actually a collaboration between multiple systems. The language model provides the reasoning. The software tools provide the capabilities. Together, they create the illusion of a single intelligent agent. This process is known as tool calling. The AI identifies a task, selects the appropriate capability, sends a request, receives a result, and incorporates that result into its next decision. Over and over again. Sometimes dozens of times during a single objective. This allows agents to move beyond the limits of their training data. Instead of relying only on what they learned in the past, they can interact with live systems in real time. Search current information, read documents, access databases, execute workflows, and interact with software across entire organizations. In many ways, this hidden tool layer is what transforms a language model into an agent, because intelligence alone is not enough. The agent must be able to reach beyond itself, to gather information, to perform actions, and to influence the digital world around it. And once agents gain access to enough tools, something even more interesting begins to happen. They start working together. Up to this point, we've focused on a single AI agent, one system, one goal, one decision-making process. And for many tasks, that is enough. But as objectives become more complex, a single agent can become a bottleneck. Because no matter how capable an agent may be, it still has limits. It can only process so much information at once. It can only evaluate so many possibilities. And it can only execute so many tasks at the same time. So engineers began exploring a different approach. What if multiple AI agents could work together? Imagine building a company. You wouldn't hire 100 people to perform exactly the same role. You would create specialists, researchers, analysts, managers, writers, reviewers. Each person contributes a different skill, and together they achieve far more than any individual could accomplish alone. Multi-agent systems apply the same idea to artificial intelligence. Instead of relying on one agent to do everything, the work is divided among many specialized agents. One agent gathers information, another analyzes it, another develops a strategy, another reviews the results, and another executes the final actions. Each agent focuses on a specific responsibility, while communicating with the others as part of a larger system. But coordinating a team of AI agents introduces a new challenge. How do you keep everyone aligned? How do you prevent agents from duplicating work, conflicting with one another, or pursuing different objectives? To solve this problem, many multi-agent systems introduce a supervisor, a coordinating agent responsible for managing the workflow. Think of it as a project manager. It reviews the objective, breaks the work into tasks, assigns responsibilities, collects results, and determines what happens next. The worker agents perform the specialized tasks. The supervisor keeps the entire system moving toward the goal. Together, they form a digital hierarchy, a coordinated network of artificial intelligences working as a team. It is important to note that this is not the only way multi-agent systems can operate. Some architectures allow agents to collaborate more directly, sharing information, negotiating responsibilities, and coordinating decisions without a single central supervisor. But regardless of the structure, the goal remains the same: combining multiple specialized intelligences to solve larger problems. Imagine asking an AI system to produce a comprehensive market research report. A research agent gathers information from multiple sources. An analysis agent identifies patterns and trends. A writing agent turns those findings into a structured document. A review agent checks for errors and inconsistencies. And a supervising agent coordinates the entire process, combining everything into a final result. What appears to be a single response may actually be the work of an entire team of artificial intelligences, collaborating behind the scenes. In many ways, multi-agent systems resemble digital organizations, teams of specialized software workers sharing information, coordinating tasks, and pursuing common objectives. And as these systems become more sophisticated, they begin to tackle problems that would be difficult for any single agent to solve alone, which is why many researchers believe the future of AI may not belong to individual agents at all, but to networks of agents working together. And some of those systems are already operating in the real world. For much of this documentary, AI agents may have sounded like a technology of the future, but the reality is, many of these systems are already here, not in science fiction, not only in research laboratories, but inside businesses, software platforms, and digital workflows operating around the world. Consider customer support. Traditionally, a customer inquiry might pass through multiple employees, reading the request, searching documentation, finding account information, drafting a response, escalating complex issues. Today, AI agents are beginning to assist with many of those tasks, gathering information, reviewing support histories, searching knowledge bases, drafting responses, and routing issues to the appropriate teams. Not replacing human expertise, but helping organizations respond faster and more efficiently. The same transformation is occurring in software development. Modern AI systems can review code, identify errors, suggest improvements, generate documentation, and assist developers throughout the software lifecycle. In research environments, agents can analyze vast collections of information, compare sources, identify patterns, and prepare summaries that would once have required hours of manual work. In sales organizations, agents can monitor leads, update customer records, schedule follow-ups, and prepare personalized communications. Across healthcare, finance, education, and logistics, similar systems are beginning to appear, not as fully autonomous replacements for human workers, but as intelligent collaborators. Digital assistants capable of handling repetitive processes, surfacing important information, and helping people focus on higher value decisions. And perhaps the most remarkable part is this: many users never realize an agent is involved at all. From the outside, the experience may look like a simple application, a chatbot, a dashboard, a support portal, a productivity tool. But behind the interface, agents may be monitoring workflows, reasoning, planning, acting, using tools, and coordinating with other agents, all in real time. Industry analysts sometimes describe this trend as ambient AI, artificial intelligence operating quietly in the background, rather than demanding constant attention from the user. Instead of arriving as a completely separate product, AI is increasingly being woven directly into the software people already use every day. Databases are becoming easier to search. Workflows are becoming more intelligent. Applications are becoming more responsive. And software is beginning to behave less like a passive tool and more like an active participant. In many ways, we are not simply building smarter applications. We are transforming the digital infrastructure that powers modern organizations. And this transformation is only beginning. Which raises a larger question. If AI agents are already beginning to transform the way organizations operate today, what happens as they become more capable tomorrow? At the beginning of this documentary, we imagined a future where a single instruction could trigger an entire chain of intelligent actions. Plan my business trip to Tokyo, research the flights, compare the hotels, build the itinerary, schedule the meetings, and coordinate the details, all with minimal human involvement. For much of computing history, that kind of workflow would have seemed impossible. Software could calculate, store information, and follow instructions, but it could not pursue goals. Today, that is beginning to change. AI agents represent a new chapter in the relationship between humans and machines, not because they are conscious, not because they understand the world the way humans do, but because they introduce something software has rarely possessed before: agency, the ability to gather information, reason, plan, act, and adapt while pursuing an objective. Throughout this documentary, we've explored how agents gather information, how they make decisions, how they create strategies, how they use tools, and how entire teams of agents can work together. What once looked like a simple chatbot has revealed itself to be something far more complex, a new kind of software architecture, one designed not merely to respond, but to participate. The future remains uncertain. Some predictions will prove correct, others will not. New challenges will emerge, new safeguards will be required, and humans will continue to shape how these systems are deployed. But one thing is becoming increasingly difficult to ignore: the age of software that simply waits for instructions is beginning to give way to software that can pursue outcomes. And if that transformation continues, the next decade may redefine what it means to interact with a computer, not through commands, not through menus, not through endless clicks, but through goals. The question is no longer whether artificial intelligence can answer our questions. The question is, what happens when it can help achieve our objectives? And we are only beginning to find out. This is the next era of computing, and it may have already begun. If you want to stay ahead of the technologies transforming our world, subscribe to ENITECH, where deep tech is simplified through cinematic storytelling. Thank you for watching, and we'll see you in the next documentary.